What if I told you that beneath your feet, miles down in the Earth's fiery core, there's a secret battle of forces, constantly erupting? But we were not talking about the kind of earthquakes that shake your house or make the ground rumble during a storm. No, this is something much more mysterious, something that has scientists scratching their heads and challenging everything we thought we knew about our planet. Deep earthquakes, events so rare, so powerful that they occur hundreds of miles beneath the Earth's surface, have recently been making waves in the scientific community. These seismic events are unlike the shallow tremors that shake buildings and cause visible destruction. Deep earthquakes are hidden from view, almost like an underground conflict that's been going on for millions of years. But why do they happen? What causes these deep, powerful forces to shift deep within the Earth, far beyond where we'd expect to see tectonic movements? And perhaps most importantly, what do these deep quakes tell us about the true inner workings of our planet? Let's dive into the hidden world of deep earthquakes, unraveling their secrets and exploring the surprising revelations scientists have recently uncovered. The first question that comes to mind when we talk about deep earthquakes is, how deep are we talking? While most of us are familiar with earthquakes that occur near the Earth's surface, these deep quakes happen at mind-boggling depths, up to 400 miles below the Earth's surface. To put that in perspective, that's deeper than the average depth of the oceans and closer to the Earth's mantle. Imagine, if you will, an earthquake happening miles beneath your feet. You don't feel it, of course, because you're on the surface, but deep below, there's an intense, almost imperceptible force at play, quietly shifting the planet in ways we can barely detect. But these deep earthquakes are no ordinary tremors. They're a silent mystery that left researchers puzzled for decades. Deep earthquakes primarily occur along subduction zones, where one tectonic plate is forced beneath another. These subduction zones, such as those found along the Pacific Ocean's Ring of Fire, are already known for producing earthquakes. However, deep quakes occur at much greater depths than their shallow counterparts. As a result, these seismic events are different from typical earthquakes in several key ways, and their occurrence below the surface presents a fascinating puzzle. Unlike shallow earthquakes, which result from the movement of tectonic plates at or near the Earth's surface, deep earthquakes occur much deeper within the Earth's interior. These events often happen between 300 and 700 kilometers below the surface, far into the mantle and upper core of the Earth. While we can't feel them, the force they unleash can still be measured with sensitive seismic equipment. But here's the big question. Why do these deep earthquakes happen at all? After all, we'd expect tectonic movement to occur primarily in the crust, not this deep into the Earth. The answer lies in the complex dynamics of subduction zones and the materials involved. But the more scientists study these deep earthquakes, the more they realize there is a lot we don't understand about what's going on beneath the Earth's surface. To understand the mysteries of deep earthquakes, we need to first take a closer look at where they occur. As we've mentioned, these deep quakes mostly happen in subduction zones, which are areas where one tectonic plate is being forced beneath another. This process, known as subduction, is responsible for creating some of the world's largest earthquakes and volcanic activity. Subduction zones are dynamic regions of the Earth's lithosphere, the outermost layer of the Earth, where two tectonic plates converge. When one plate is forced beneath another, the plates can become locked due to friction. Eventually, pressure builds up to a breaking point, causing an earthquake. This is the process behind many shallow earthquakes, but what's happening deep beneath the surface? Deep earthquakes, scientists believe, are occurring as a result of the intense pressure and heat deep within subduction zones. As the oceanic plate is forced into the mantle, it doesn't just melt away. In some cases, it can experience what's known as phase transitions, transformations in the material's structure due to the extreme pressure and temperature. These transitions can cause the minerals within the plate to suddenly shift, releasing energy in the form of a deep earthquake. The deeper the plate goes into the Earth's mantle, the more it undergoes mineral changes. When oceanic crust is forced into the mantle at subduction zones, certain minerals within the plate begin to undergo phase transitions. Essentially, the minerals transform into new types of minerals under the extreme pressure and temperature conditions of the mantle. This process could explain why deep earthquakes happen. As the minerals change their structure, they could create stresses within the plate that result in seismic activity. While we've known about phase transitions for years, scientists are still uncovering how these mineral shifts relate to the timing and intensity of deep earthquakes. Unlike the dramatic surface-level quakes we're used to hearing about, deep earthquakes are not easily detectable. They occur far beneath the Earth's surface, making them difficult to study. But thanks to advancements in technology, scientists are beginning to unravel the secrets behind these elusive seismic events. Seismic waves, vibrations that travel through the Earth after an earthquake, are what help us detect and measure deep earthquakes. These waves can travel through the Earth's layers and are recorded by seismographs placed around the globe. But because deep earthquakes happen so far below the surface, their seismic waves are more difficult to trace and measure than the waves of shallow earthquakes. The fact that these deep quakes are hidden beneath layers of rock means that the seismic waves they create are often less powerful when they reach the surface. This makes it harder for scientists to detect and study the full effects of these deep earthquakes. Despite the challenges, advancements in seismic technology are helping scientists detect deep earthquakes with greater accuracy. Seismologists now have access to more sensitive equipment and global networks of seismographs, allowing them to trace seismic waves more precisely and track even the smallest tremors deep within the Earth's interior. By studying these seismic waves, scientists are learning more about the dynamics of deep earthquakes. We can now detect quakes that occur as deep as 700 kilometers beneath the surface, events that were previously undetectable. The more scientists study deep earthquakes, the more they realize that these seismic events are revealing deeper secrets about how our planet functions. Not only do deep quakes provide clues about the Earth's mantle and subduction zones, but they also challenge some long-held assumptions about how the Earth's internal processes work. One of the most exciting discoveries made by studying deep earthquakes is the revelation of new insights into the Earth's mantle. These quakes happen so far beneath the surface that they offer scientists a unique opportunity to study the conditions of the mantle, a part of the Earth that is notoriously difficult to study directly. By analyzing seismic waves from deep earthquakes, researchers are gaining valuable information about the temperature, pressure, and composition of the Earth's mantle. This can help us understand how the mantle behaves, how heat is transferred within the Earth, and what drives tectonic movements on a global scale. Deep earthquakes also challenge our understanding of plate tectonics. For decades, scientists believed that the majority of seismic activity occurred near the surface of the Earth, where tectonic plates meet. However, deep earthquakes show that seismic events can occur much deeper within the Earth's interior, which suggests that the processes driving tectonic movement are far more complex than we thought. These earthquakes could also imply that subduction zones are behaving in ways that scientists didn't previously understand, potentially leading to new theories about plate tectonics and the driving forces behind earthquakes. While deep earthquakes are rare, their potential to impact the surface of the Earth is significant. If deep quakes are linked to tectonic shifts, they could have long-term consequences on the Earth's surface, triggering large-scale seismic events, volcanic eruptions, or other geological phenomena. Some scientists speculate that deep earthquakes could be a precursor to larger seismic events at the Earth's surface. If the pressures created by deep earthquakes are released along the subduction zone, they could trigger surface earthquakes, tsunamis, or volcanic activity. This connection is still being studied, but it suggests that deep earthquakes could be a key player in the larger seismic picture. Because deep earthquakes are often linked to subduction zones, there could be a direct impact on volcanic activity. If these deep quakes are caused by the shifting of tectonic plates and the mineral phase transitions within the oceanic crust, it's possible that they could contribute to the buildup of pressure beneath volcanoes. This could lead to volcanic eruptions or changes in the pattern of volcanic activity, which could have widespread consequences. Deep earthquakes are more than just rare seismic events. They are a window into the hidden workings of the Earth. These mysterious quakes challenge everything we thought we knew about plate tectonics, mantle dynamics, and the forces driving our planet's evolution. As we continue to study deep earthquakes and analyze their seismic waves, we're uncovering the deeper secrets of our planet, helping us understand the forces that shape our world and prepare for future seismic activity. While we may not feel these deep earthquakes on the surface, their impact is far-reaching. They remind us that there is so much more happening beneath our feet than we can see, and that the Earth's mysteries are far from being fully revealed. As we continue to peel back the layers, who knows what we might discover next?